Hey, it's me again. I want to show you one more strategy that you might really like for the lesson on identifying equivalent expressions. I showed you how you could use distributed property and combine like terms to make them actually the exact same. But there's another strategy that you actually might like more. So I want to give you the opportunity to learn that strategy in case it really makes sense to you. So the strategy is this: replace the variables with a value, and if they're equivalent, you'll get the same answer for both of them. Here's what I mean by this. On this question that we did earlier, we did the distributed property, we combined like terms, and we saw that they were equivalent. Okay, but another thing we could do is we could set values for those unknown variables. And I like to use like 1 and 2 because those are really easy. And then I can solve it and I get an actual answer, evaluate, right? I'm going to use order of operations. So 5 times 3 is 15. On this one, I'm going to use the exact same values for my variables and solve using order of operations. So I'm going to do everything the same. All I'm doing is substituting the variables, the values with the variables. Okay, oh, so I don't want B. I can actually now make that 2. Okay, so order of operation will be 9. And then plus, that's 6. 9 plus 6 is 15. So do you see how those are equivalent? Because when I substituted the exact same values for the variables, I got the same answer. Let me give you another example, or you can do this one with me. We also did this one in the video before, and we saw that they are also equivalent. Okay, and you can use anything for the values. I can use like 10 and 5 now. So when you do this, use values that are easy to work with for you. So 7 times 10 plus 5 plus 3 times 10. And this will be 10 times 10 plus 5. All right, order of operations. That gives me 35 plus 70, which is 105. Okay, order of operations here will give me also 105. So those are equivalent. What does it look like when they end up not being equivalent? So we did these and this was not equivalent. What if we did A equals 2? All right, so we have 9 times 2 times 3. That's 18 times 3, which is 3, 4, 5, 54. Okay, 24, 3. Oh, what in the... That was kind of cool. Okay, and then this would be 12 times 2, which is 24. Do you see how they end up being different answers? So that's another way where we know, okay, those are not equivalent. Okay, try this one now. We know that they are not equivalent. Try it for m equals 2 and n equals 10. 2 plus 10, and this will be 10 times 2 plus 10. That gives you 12 times 10, which is 120. And then 20 plus 10 is 30. Okay, and you see how they're not equivalent? So try this one if you feel like it. Choose whatever you'd like for t for your variable. 1 is always an easy number to work with, right? So 4 plus 5 times 6 times 1 plus 1. This would be 9 plus 30 times 1, which is 30, right? So that's 6 plus 1 is 7. That's 35. 4 plus 35 is 39, and that one is 39. Oh, cool beans. So those ones actually are equivalent, okay? All right, that is the strategy I wanted to teach you. Maybe you'll love it. Maybe you'll just keep doing the distributive or the associative property or combining like terms to see if they're equivalent. But this is a good strategy to know if you're on a test and you really want to make sure you've got it correct. Now you've got 2 ways to solve these questions.